Hello, today we're going to start Chapter 2. And the Chapter 2 title is called The Rational Numbers. When I see the word rational, sometimes I think of the word fraction because that's really what we're going to be talking about with this chapter is a lot of fractions. The first thing we're going to do is simplify rational expressions. Well, in other words, we're going to be simplifying some fractions. A rational expression is the quotient, and quotient means divided by. And usually when we divide two things in math, we set it up as a fraction. So the quotient of two polynomials. For example, m squared n over 3m n cubed. There's a fraction. It's got a couple of variables in it. Here's another fraction, x squared plus x minus 12 over x squared plus 10x plus 24. 5 over y is a very simple rational expression, and negative 2/7 is another rational expression. In a rational number, a over b, this is a rational number. A and b are integers. And b cannot be equal to 0. And if you remember from your previous math courses, you can never divide by 0. It'll give you an undefined value like 7 over 0 or 3 over 0. So b can never be 0. Now in a rational expression, a over b, a and b are some kind of polynomials. But b can never be equal to 0 again because you can never have a 0 in your denominator. So in these examples up here, the first three are rational expressions because we have variables in here, and negative 2/7 is just a rational number because there aren't any variables. Now just remember, you can't divide by 0, it's not possible, and if your denominator is 0, it's really called an undefined fraction, or it's meaningless. Sometimes we're asked the question, for what values of x? For what values of x? So we're going to be solving for x here. Is each of the expressions not defined, or in other words, undefined? So what we're going to do is something is undefined, it means the denominator is 0. So it doesn't matter what's in the numerator. You can just ignore the numerator. You might want to write that down. Ignore the numerator. It just doesn't matter what it is. So you're going to ignore the numerator, and you're going to set the denominator equal to 0. And then you're going to solve for x. So for the first example, the 5 doesn't matter, but we're going to set x minus 3 equal to 0. Add 3 to both sides, and you get x equals 3. So the value of x when it's equal to 3 will make 5 over x minus 3 undefined. In the second example, we'll just set x squared minus 16 equal to 0. And this is a difference of two perfect squares, so you have x plus 4 and x minus 4 equal to 0. And what does x equal on the left? X equals negative 4. Negative 4 plus 4 is 0. Or x equals positive 4. So there are two values of x that make this fraction undefined. In number 3, remember the 3x doesn't matter. And in number 2, x plus 2 doesn't matter. It's just the denominator. So we're going to set 2x minus 1 equal to 0. We're going to add 1 to both sides, 2x equals 1, and then divide both sides by 2, so x equals 1/2. So the value of x equals 1/2 would make this undefined. And the last example here, we're going to set x squared minus 4x equal to 0. Doesn't matter about the numerator. Let's factor this. X times x minus 4 equals 0. And when you have an x on the outside of the parentheses, you just set it equal to 0 by itself. And then this x equals 4. So you have two values of x. X equals 0 and x equals 4 that would make this an undefined fraction. So this is really important to know what values of x make fractions undefined. Sometimes you're going to be asked to reduce to lowest terms. So a rational expression is reduced to lowest terms when its numerator and denominator have no common factors other than 1 and negative 1. And so you're going to be asked to reduce this. To reduce it, you're going to factor first. That is always the first step when reducing these things, and we're going to get a lot of practice factoring here, both the numerator and denominator. And once they're completely factored, you're going to divide out, and we often use the word cancel, the common factors. So for this first example, 2x minus 6y, well, the numerator can be factored because there's a GCF of 2. So when you take the 2 out of the numerator, you're left with x minus 3y. And in the denominator, there's a GCF of 4. So you're left with 4 times x, again, minus 3y. So now you have common factors. You have an x minus 3i, that's a factor. X minus 3y, that's a factor. So you can just lightly cross those out. I'd like to see what's underneath them, so just write it lightly. And you're left with 2 over 4. Well, 2 over 4 can also be reduced to 1/2. And that's your final answer. So this original fraction reduces down to 1/2. The second example, you have a 4x as your GCF. And when you take the 4x out, you're left with x plus 2. And in the denominator, it looks like 6x squared is the GCF. And again, you're left with an x plus 2. Well, the x plus 2's cancel out, and you're left with 4x over 6x squared. Well, the 4 over 6 can reduce because it has a common factor of 2. So divide out by 2 and you get 2 on the top and 3 on the bottom. And an x divided by x squared, well, this x cancels out completely and this x squared just reduces down to one single x. So your final answer is, 2 on the top, 3x on the bottom. And that's the end of that problem. Number 3. X squared minus 25 factors into x plus 5 times x minus 5. And then in the denominator, we have a GCF of 3, and you're left with x minus 5. The x minus 5's cancel out, and you're left with an x plus 5 in the numerator. If you want to put parentheses around, you can, but you don't have to. And then a 3 on the bottom, and that's the end of that problem. And in this last example, you can factor the top. The factors of 3 that add up to 4 are 3 and 1. And in the bottom, the factors of 1 that add up to 2 are 1 and 1. So now you have an x plus 1, top and bottom, and what you're left with is x plus 3 on the top and x plus 1 on the bottom. And do not cancel those x's because they are not factors, they are called terms. Do not cancel these x's. Exclamation point. They are terms, not factors, because of this plus sign right here. This plus sign makes it a term, not a factor. They are terms, not factors. So that's a real danger here. Some people just like to cancel everything that they can see that's the same on the top and the bottom, but please do not cancel anything with a plus or a minus in between those numbers. So there's your final answer, x plus 3, if you can read that, x plus 3 over x plus 1. Going on to page 2, we have some more examples that we can just factor. So the factors of 16 that add up to 8 are 4 and 4. And here's a DOTPS, difference of two perfect squares, x plus 4 times x minus 4. And now we have x plus 4's that are common, and what we're left with is x plus 4 on the top and x minus 4 on the bottom. Now that's the final answer because you cannot cancel those x's. They are terms, not factors. Don't cancel the x's, please. Number 6. Well, this numerator has a GCF. There's an x squared in each one of those terms, so I'm going to take the x squared out. And there's a y in each one of those terms, only one, so I'm going to take one of the y's out. So when I divide x cubed y by x squared y, the x cubed over x squared becomes an x, and the y over y cancel out. And then when I take x squared y squared, divide out an x squared y, well, the x squareds go away, and y squared over y is just a y. That's a tricky factoring. So take a look at that. Maybe you want to pause that for this video for a moment, just to take a look at what happens when you divide each one of those by x squared y. And in the denominator, again, we have an x squared in both terms, and we have a y in both terms. And when we divide this out, we're going to get one single x because the y's will go away, and we'll get one single y because the x squareds will cancel out. So when you get down to this point, the things that you can cancel, you have an x squared over an x squared, they're factors because there's no plus sign there. You have a y and a y, those are factors. You can cancel the factors out. So what you're left with here is an x plus y on the top and an x minus y on the bottom. And those x's can't cancel because they are terms. Because of this plus sign and because of this minus sign, they're called terms, they're not factors. So this is the final answer here. Please do not reduce this anymore. This is a real important kind of difficult question, number 6 is. Number 7, I see a GCF, which is a 3. So when I take a 3 out, we're going to be left with x squared minus 48 divided by 3 is 16. And in the denominator, the factors of -8 that add up to -2 are -4 and +2. Well, I can go one more step in this factoring. X squared minus 16 is really the same thing as x plus 4 times x minus 4. So now what we have is an x minus 4 in the bottom and an x minus 4 in the top, but there's nothing else that's common that can cancel, so we're left with a 3 on the top and an x plus 4, and then on the bottom we're left with an x plus 2. If you want to distribute the 3, that's fine, but it's not necessary. That would be the end. Number 8, looks like we have factor in, factor out here. So 2 times -5, I'm going to pull this off to the side. 2x squared minus 9x minus 5. 2 times -5 is -10. Factors of -10 that add up to -9 are -10 and +1. So now I'm going to put a 2x in both sets of parentheses. I'm going to subtract 10, add 1, and don't forget the last step is to divide out by 2. This factor here. So when you divide these out by 2, you're going to get, now I'm going to just pull this down, 2x minus 5 on the top. I'm sorry, 1x. Oops, that's a mistake. Sorry. X minus 5 on the top. 2x plus 1 on the top, because that would be this numerator. And on the bottom, this is the difference of two perfect squares, DOTPS. I see 4x squared is a perfect square, 2x plus 1, 2x minus 1. So we have factoring top and bottom, and I see a 2x plus 1 as common factors that can cancel out. So what we have in the end is an x minus 5 on the top, a 2x minus 1 on the bottom. Those x's do not cancel, they are terms, so that's the final answer. Now if you want to factor out a -1, or all of these examples have a situation where you can factor out a -1. What we have is x minus 3 over 3 minus x. Let's just plug in some numbers for x and see what we get. Let's say x is 10. If we have x minus 3, which is 10 minus 3 over 3 minus 10. Well, what's 10 minus 3? 10 minus 3 is 7. What's 3 minus 10? -7. 7 over -7 is -1. What if we plug in a 12 for x? 12 minus 3 is 9. 3 minus 12 is -9. 9 over -9 is -1. No matter what number we put in here for x, you can choose any number you want. When you plug it in for x, if you do x minus 3 over 3 minus x, that same number, you're always going to get a -1. So what really happens here is when you have two subtractions and they are in the opposite position, positive x here, negative x here, -3 here, +3 here, they can cancel out, but they cancel out to a -1. So this whole answer reduces down to -1 no matter what you put in for x. In number 10, you have a y minus x minus y. Well, this is a subtraction binomial. And a subtraction binomial, when they're both subtraction and they are in the opposite order, you can cancel them both out, but they cancel to -1, and I always put the -1 on the top. So this reduces down to a -1 on the top over 2 on the bottom. In this example, x squared minus 4 can factor into x plus 2 times x minus 2. Well, I put number 11 in here to fool you because 2 plus x and x plus 2, notice these are plus. Those other two are minus. If they're both 2, think of any number. 2 plus 3 is the same thing as 3 plus 2. 2 plus 10 is the same thing as 10 plus 2. No matter what, 2 plus x and x plus 2 are the same thing. So when you cancel something totally out, replace it with a 1, a positive 1 this time, not a negative 1. And so your final answer is 1 on the top and x minus 2 on the bottom. And that's it. Don't forget the 1 on the top. In number 12, you have a GCF. I see an x in both terms. I see a y in both terms. And when I take an x and a y out of this first term, I get 2y minus, when I take 1x and 1y out of here, I'm left with 3x. And on the bottom, it looks like I have a 2 for a GCF and an x, but no y because there's no y in this term. So 2x is the only GCF here. So when I divide 6x squared out by 2x, I get 3x minus 4 divided by 2 is 2, x divided by x is 1, and y is what we're left with. What we have next is a 2y minus, remember with subtraction, if they're both in opposite positions, they can cancel out to a -1. And when you have an x on the top, there's no plus signs. These are factors, not terms. They can cancel. Once there's a plus sign in there, you couldn't cancel those, but this is multiplication, so you can. And so what we have in the end is we have a -1 times y in the top, which is -y. On the bottom, we have a 2. And that's it, because everything else canceled. So that's kind of a funny way of writing this. I guess this 2 should be more centered. -y over 2 would be your final answer here. Everything else canceled. In this example, we have a DOTPS. We have 2 perfect squares, 1 plus 3x, and 1 minus 3x. And in the bottom, we have a GCF of x. And we're left with 3x minus 1. Don't forget that 1 here. And 1 minus 3x and 3x minus 1, they will cancel out to a -1 because they're subtraction in the opposite order. And that's all we can do with that one. So in the top we have -1 times 1 plus 3x, notice the parentheses, or if you wanted to negate everything you could, don't have to, and on the bottom we're just left with an x. This negative really could go on the top or on the bottom or out front, and it's all the same. And then the last thing we're going to do here today is multiply 2 times -14. This is factor in, factor out, FIFO. And you get -28. Factors of -28 that add up to 3. I think it's 7 times 4. I think it's a +7 times a -4 would give you that. So I'm going to just rewrite the top. And on the bottom we have 2x and 2x. And a +7 and a -4, but I have to divide the whole thing out by 2, says factor in, factor out. So this becomes x minus 2. And now we have a 2 minus x on the top. This is the bottom, x minus 2 after the factoring is done. So 2 minus x and x minus 2 reduces down to a -1 on the top and a 2x plus 7 on the bottom. So the final answer here is -1 over 2x plus 7. So I think I've given you examples of about everything you could possibly see, almost anyways. Have a good night. See you tomorrow.